as I said, the BBC Micro was this machine that was built back in 1981, and it was based on a 6502 processor, which to me is a lovely processor. It's an 8-bit processor with a nice simple instruction set, it's a flat memory model. If you're trying to learn assembler code, it's a wonderful place to start because it's nice and easy. So I really like that. When the people at Acorn, who were the company who manufactured the computers, started thinking about what they were going to do next, they decided that the 6502 wasn't going to be powerful enough. 8-bit processor wasn't going to be suitable for what they had in mind. They wanted to get into business machines, and they wanted to have something more powerful. So they looked around and they figured out that actually designing your own processor wasn't that hard. So these are people who were at Cambridge, so for them things are a little bit different. If I was there, it might be, I'm not designing my own chip. But anyway, they thought, yes, let's look around, figure out how to build our own chip. And at that time, there was a research project going on just down the road from here in Berkeley about RISC, Reduced Instruction Set Computing. The idea that you had less instructions which you could execute faster. So rather than having more complex instructions, you had a smaller instruction set, but you could execute them much more quickly. And so the idea is that the efficiency is better. The other thing is that if you look at machines that have, or processors that have more complex instruction sets, there was a survey that was done, or an analysis that was done, which looked at the Unix kernel. And they identified that only 30% of the instructions of a Motorola 68000 were actually being used when you ran the kernel. So why have all these extra instructions if you're not going to use them? Make it a smaller instruction set, make the silicon easier to produce. So just as a useless aside here, Motorola 68000, another one of my favorite processors because it has a flat memory model. Anybody know why it's called the Motorola 68000? I know it's produced by Motorola, so you don't get a point for that. No, it's called the Motorola 68000 because it had 68,000 transistors in it. Just like I say, useless piece of information for you. So the idea was that they wanted to create a machine that had less instructions, but potentially more registers, so that you could do more things using very quick references to memory, rather than having to go to main memory, which was slower. And in fact, one of the architectures that came out of that was the SPARC architecture. And that was what we did at Sun for a long time, and now at Oracle. So then, what they actually produced was the Acorn RISC machine. And that was the first, if you like, ARM. Because if you reduce it down to its, I suppose it would be ARISCum, but they actually called it the ARM. So that was a 32-bit data address lines, 26-bit address space, and 27 registers. And the first machine that they produced of that was the Acorn Archimedes. I saw not many people put their hands up and say they had a BBC Micro. Anybody have an Archimedes? Oh, okay. Andrew did. Oh, and at the back as well. Great. Okay, 2 people. So then time went on, and they basically spun off the chip manufacturer, or the chip design business, I should say, from Acorn, and they renamed the ARM the Advanced RISC Machines. So that's where ARM came from. Now, if you look at the features of the ARM processor, it is a 32-bit RISC architecture. So it's designed on the same ideas that they had before. Interestingly, ARM now accounts for about 75% of the embedded 32-bit CPU market. So if you've got an iPhone, if you've got a lot of different Android phones, they're all using ARM processors inside. There's lots and lots of places where ARM processors get used. And in fact, last year, they sold over 8 billion ARM-based chips. And that brings to a grand total of over 30 billion. In fact, the number that was told to me yesterday was about 35 billion in total. Absolutely 0 of those were manufactured by ARM, which is really quite impressive because basically they design the chips and then they sell the designs to other people. Other people then put them into packages, fabricate them, and actually produce chips from them.